Hello, everyone. Welcome. My name is Flavio Popescu. In a second, I will introduce my colleague, Ciprian Țibea from StruSoft, Romania, who will give you an focused analysis on the time history analysis feature in FEM-Design. The time history analysis feature is a new feature, and we are very excited to have a look at it together with you. We are using GoToWebinar today. Please type in your questions in the questions field, and we will get back to you with the answers. First, I want to just give you a short introduction to StruSoft and FEM-Design, and then I will pass the floor on to Ciprian. Today we will talk about FEM-Design, but StruSoft has a wide range of structural analysis and calculation software. WinStatic is a smaller program which deals with individual element calculation and design. And I mean beams, columns, frames as a whole. And you can calculate and design concrete and steel elements. BIM Energy, a energy calculation and optimization software. Impact, precast and reinforcement for factories. And pre-stress, which deals with pre-stressed concrete elements. StruSoft spans on more than 30 years. Right here, I have pictured only the more recent timeline. It was part of Skanska, and it has evolved, and it has also evolved its software and range of software. And right now, the latest version of FEM-Design, which we will talk about today, is FEM-Design 20. Another milestone this year is the partnership with BuildSoft in the Netherlands. StruSoft has users around the world, as you can see from this map. We have offices around the world, including the headquarters in Sweden, Malmö, Sweden, offices in Denmark, Romania, Finland, and also in Asia, like the Philippines and India. Let's talk a little bit about FEM-Design. Real short introduction. FEM-Design is very useful when it comes to collaboration with other software like Graphisoft Archicad, Tekla, Revit, and parametric modeling tools like Grasshopper or Dynamo. It is very used and useful when it comes to modeling from CAD drawings. You can import 2D drawings and start building up from 2D into 3D. You can also import 3D CAD drawings. FEM-Design is a modular software. So you have the analysis engine where you define the structured loads, customize the finite elements, and run different types of analysis and get the results like deformations and internal forces and stresses. That's the calculation engine. Then you have the design modules, which are concrete, steel, timber, and composite design, all of which you can get detailed calculation reports according to Eurocode. Some special features which make FEM-Design very special are the concrete section analysis, where this is a nonlinear analysis tool which takes into account the reinforcement in the concrete and reduces the stiffness of the material with the appearance of cracks. It is an iterative process which looks after the cracks that appear, reduces the stiffness in those nodes where the cracks are, and then recalculates, and so on. A very powerful module is the 3D soil module, which handles soil as 3D finite elements. You can get a very realistic interaction between the soil, foundation, and superstructure, and analyze it as a whole, as one big model. FEM-Design is also special when it comes to development. Our development focuses a lot on user experience. A very good example for this is the KCT workshops. The KCT workshop is a long weekend, a yearly long weekend, where we get all the key users, which use FEM-Design a lot around the world, and we meet with them in Budapest in Hungary. Of course, this last year, or in 2020, the meeting was online. But in this long weekend, all the users, all these key users, get together with the developers, and exchange information and experiences, and actually contribute directly to the development of the software. They make suggestions and give feedback on their experience with the software, and the developers take these ideas and turn them into new features. FEM-Design has a new complete version every year, which launches in January, and several packages released during the year. Okay, I will hand over the presentation now to Ciprian, who will give you a closer look at FEM-Design, and namely the time history analysis. Ciprian, the floor is yours.
Good afternoon, everybody. Thank you for being with us today. First, I want to quickly have a look on some of the new terms or old terms, however you want to call them. And mainly, let's start with the earthquake load. And what is it? So as you can see, it's an inertia force depending on mass, stiffness, and energy absorbing capacity. Then you were probably asking, what is time history analysis? Well, basically, it can calculate the response of the structure at every time step specified. And then the response spectrum analysis, which was a feature already in FEM-Design in earlier versions, which is derived from time history analysis, or it can use direct design spectrum. All right, and let's see how the seismic analysis is classified. So as we can see, this classification is static analysis and dynamic analysis mainly. Most important of all of those, which are still in use, is the response spectrum analysis and time history analysis. Power spectral density analysis is not really common type of analysis. It uses a lot of resources and therefore is not so accurate as well. All right, now before we jump into the models, I want to just have a closer look of our at our FEM-Design wiki page. And here, if you type time history analysis like this, and you search for it, our colleagues have also placed some very useful data here, but also they made a guideline which you can download directly from the website. And yeah, this is the guideline. It's quite nice, really detailed, and you will find a lot of information here. All right, now that we covered the biography parts, let's jump into the actual features. So as you can see, we got some extra buttons here. And the first one is the ground acceleration. So in this particular case, I have just one accelerogram, but you can have many of them, and FEM-Design will also calculate the average one. Basically, after you have, you can copy paste the data from an Excel file directly here. You can do combinations between them and so on and so forth. So basically, after you have the accelerograms introduced, you just click the response spectra, and then you click the calculate, and it will calculate the response spectra based on the input accelerograms. And then I can set the spectrum, and if I go into my seismic load, I see it here as a unique spectrum. So this was the first feature that I wanted to show you, mainly how to go from accelerograms to the response spectrum. Now, if we go to the next model, basically we have a multi-story simple structure with some loads on it, and of course with some sinusoidal accelerograms. Now, in this particular case, we also made a combination between those accelerograms. You can use here different factors if you want. All right. So basically, we can proceed with the time history ground acceleration for this one. Here in the setup, you have the integration scheme, which you can use either Newmark or Wilson Theta. We have the Raylight damping matrix. You have both of those coefficients and the way they are calculated in the document that I showed you previously. And this level acceleration spectrum is basically a feature that was requested by users previously, and it takes into account of the additional machines that might be present on some floors and their own accelerations in relation to the structure. But we will get to that later. All right, so now that the setup is complete, we can just calculate the structure and see what kind of results do we get after calculating it. It is a time-consuming type of analysis because basically it calculates all the results in each time step. So you can imagine that the time steps are quite a lot.
Ciprian, while
Yes.
while we do this calculation, I have some people who are asking about the presentation for the time history analysis. explanation.
Right. This one?
Yes.
Yeah,
Did
okay.
you show anything else about this, or can people read some more about the time history?
Yeah, as I said, the most comprehensive book that we have is the manual that was released by our colleagues, and that can be found into our FEM-Design wiki with the download link.
Okay.
So in case you missed it, you go to FEM-Design wiki, you click the time history, and then you click this download the full guide button. Yeah. It takes a bit more, but it will soon be ready. Maybe until then, we can look a little bit into the contents of this book. So the Raylight damping matrix that we were talking about with the two coefficients, and my analysis is done. All right, so let's have a closer look to the results. As you can see, we have the transitional displacements, and we have this ruler that we can go to a different time step, and let's see, display. All right, we can also do an animation, for example, as we are used to for the seismic load, for example. And basically it will go through all of the time steps individually. Then until the animation is ready, we can have a look at the results. So except the translational displacements, we have the rotational displacements, we have accelerations, we have reactions, and we see this one, which is the level spectra, which we will go as the last feature presented. It's taking quite a bit, maybe also because my laptop is not so powerful as a desktop. We will have the opportunity to go into detailed results in any of those into accelerations or into the level spectra, etc. And we will see the differences on all three directions in terms of accelerations and so on and so forth. So I will not click the animation button in this webinar, so we don't waste more time, but now it's almost ready. So for this particular result display method, I will let it run this time. So this is how it's evolving in time, as you can see in the animation. All right, so for example, as I said, we can look at the rotational displacements, and we can go at any given time we want, or we can just take the maximum. Also at the accelerations, and for example, if I want to have a closer look into a detailed result into one point, as I said, I can look at the acceleration in those three directions presented down below, and I can do that for any point in the structure. And then we had this, of course, we had the reactions as well. So, and we had this level spectra. Now, basically, this is concentrated mass of a level and the way it evolves in all three directions. So the same as the last detailed result, green X direction, red Y direction, blue Z direction. All right, so this covered this type of analysis. And let's go to our last feature. Now, in this particular model, as you can see, we have a simply supported plate with some concentrated loads on top of it. And we have a function, ground acceleration, no combinations. And if I go to the analysis tab and I select the time history excitation force, which I already run previously, so we don't waste more time, we can see in the results that we have two types of displacement, statical displacement and dynamic displacement. We can select the absolute maximum, and of course there is a slight difference in this case, as you can see, from 47 to almost 50, and this is because the dynamic factor is also taken into account. And it's the same for the rotational displacements. We can also have a look at the accelerations, reactions in any given point or at the maximum moments, so basically all the shell internal forces. Then we have the dynamic factors and the normalized dynamic factors, which if we go, for example, again into a, let's see, dynamic factors, normally it should have shown me both of them, both statical and dynamic. All right. So normally here we would have had two graphs, one with a dotted line, which is the static, and one with a continuous line, which will be the dynamic, and the difference between them. So basically that was all the features newly introduced in this time history analysis. Something worth mentioning is that this first first feature introduced is a linear time history analysis. So it's not non-linear. That means that crack analysis or second order analysis and so on and so forth will not work with it at the moment. So that was all for today. Thank you very much. We hope that you enjoy all those new features introduced in FEM-Design 20, and we are waiting for you to give us a call, and yeah, we will come back to you either for testing or just to find out what other features are present in FEM-Design.
Thanks, Ciprian. I just wanted to conclude by encouraging you to go to our website, StruSoft.com. Here is the portal to all of our software and services, including support and FEM-Design. If you're not using FEM-Design yet, you can go to Get Started Now and fill out the form for a trial license, and you will get a trial license to try the program out. That's the best way to learn it and figure it out. Also, we have a YouTube channel on StruSoft Official. Make sure to subscribe, and then you will be notified when we post either recorded webinars Here we have also some tutorials for FEM-Design and also for our other software. Thank you once again to everybody. Thank you, Ciprian, for the presentation, and see you next time. Have a great rest of the day.